LDR means light dependent resistor. So LDR is also an electronic. LDR is also the transducer. Okay, which convert the non-electrical quantity like light. Okay, will light into an electrical quantity like resistor. So um, it will act on light intensity. Okay, if this is your LDR, then it will act accordingly. Like here, current will flow from like this in this direction. Okay, and light is coming on this LDR. This is the light. Okay, in this direction. So if you increase the light intensity, then the resistance of this LDR will get decreased. Okay, so when the resistance of this LDR will get decreased, then a high current will flow. Okay, so this component act according to the light intensity. If you increase the light intensity, then the temperature will get increased, and when the temperature increase, then the resistance of LDR will get decreased. So you can say that it has a negative temperature coefficient. We have two types of temperature coefficient. You know temperature coefficient. Temperature coefficient, we have two types. One is the positive temperature coefficient, and second one is the negative temperature coefficient. So positive temperature coefficient means if you increase the temperature, then the resistance will get increased. So this is the positive temperature coefficient of resistor. Okay, positive temperature coefficient of resistor. I will send you all these slides. So if you increase the temperature coefficient, if you increase the temperature, then the resistance will get increased, and that is known as positive temperature coefficient. And if you increase the temperature, then the resistance will get decreased, and that is known as negative temperature coefficient. So you can say that LDR has negative temperature coefficient. Like if you increase the temperature, then the resistance will get decreased. So negative temperature coefficient of resistance. And all semiconductor is made up from negative temperature coefficient. Like any semiconductor, if you increase the temperature, then the resistance will get decreased. Means the electron in the conduction band will get increased. As you study and as you know that we inside atom we have conduction band, and here we have valence band. Here we have lots of electrons. So if there is no electron present in conduction band, then we said that this object is the insulator. So in insulator, there is a huge forbidden gap. This is the forbidden gap. Forbidden gap. And this forbidden gap will bring the differentiation in between conductor, insulator, and semiconductor. Like in conductor, this forbidden gap will be too much small. Okay, like electron will easily move toward the conduction band. In conductor, in insulator, this forbidden gap will be huge, that the electron will be unable to move into the conduction band. And in semiconductor, that will be the gap will be in between conductor, which is very small, and in between insulator, which is very huge. Okay, so if this is for the insulator, then for a conductor, it will be like this. Very small gap. For insulator, it will be in between. This is for conductor. For insulator, it will be in between like this. EV. So if the temperature is equal to, if the temperature is normal temperature means if the temperature is 25 degree, normally we take the temperature, we take the 25 degree C as a normal temperature. So if the temperature is 25 degree C, then you will find electron here. Okay, you will find electron over here. But in semiconductor, there will be no electron in conduction band at room temperature, like 25 degrees C. Okay, like if electron come in the conduction band, and when you connect the voltage supply across this component, this object, then you will get electron. That electron will easily flow in that in this component. But if you connect the semiconductor, okay, semiconductor component, a semiconductor object across the potential difference, okay, across the voltage supply, then and if the temperature of the room is normal, like 25 degrees C, then it will act as a resistor, okay, because no electron is present in the conduction band. But if you increase the temperature, then it means that this object is getting energy from the environment, from the room. Okay, so here we have electron. So that electron will get energy from the room. Okay, and when it get energy from the, so it will jump and it will cross this band and it will come over here. So if you increase the temperature, now you will have electron in the conduction band. Okay, so there is electron in the conduction band, and there is electron in the conduction band. And when you apply the supply voltage across this object, then this object will allow the current. Okay, so you can say that the resistance will get decreased. If you increase the temperature, then the resistance will get increased. Resistance will get decreased. Okay, and in room temperature or less than the temperature of the room, normal temperature, like less than 25 degrees C, then no electron will present in the conduction band, so no current will flow across this object. So you can say that the resistance of this object is high. Okay, so it has a negative relation. It has a negative relation, like it has an inverse relation. If you increase the resistance, so if you increase the temperature, then this electron will get energy and move toward the conduction band, so resistance will get decreased. And if you decrease the temperature, then this electron will be unable to move into the conduction band because it has a low energy, less energy. So you can say that the resistance will get increased. Okay. So LDR is your negative temperature coefficient. Uh, it has a negative temperature coefficient. If you increase the light intensity, then the temperature across this resistance will get increased, and the resistance of this LDR will get decreased. So this is your transducer. So it has a negative relation. Increasing temperature means increasing the light intensity. So if you want to draw a graph between the intensity and between the resistance, like if this is the intensity, light intensity, and here we have a resistor, then it will have, the curve will be like this. Like if you increase the light intensity, so you will move like this, then the resistance will get decreased. Okay, so it has an inverse relation. So this is all about the LDR.